This is our lab on Le Chatelier's principle. The purpose of Lab 7 was to investigate 6 equilibrium systems to gain a deeper understanding of equilibrium in Le Chatelier's principle. Hypothesis was that we believe that the rate of the reaction will be faster when in the hot beaker, and there will be a change in the color of the solution when crystals are added that show the reaction progressing, but then remain constant. Here are the answers to our pre-lab questions answered for the introductory activity. Materials for the introductory activity include iron 3 nitrate, potassium thiocyanate solution, sodium phosphate, distilled water, a 250 milliliter beaker, a 50 milliliter graduated cylinder, ice, a labeling pen, petri dish, pipette, 2 spatulas, 2 test tubes, a test tube rack, and a wash bottle. Here is the summary of procedures Part A and Part B that will be conducted in the next few slides. On the far left, 20 milliliters of potassium thiocyanate is poured into a petri dish and a clear solution is observed. 3 drops of iron nitrate are added in the middle picture, and the video on the far right shows the swirling of this that creates an orange transparent solution. On the far left, a picture of a small amount of potassium thiocyanate is added to the dish, and on the video in the middle shows the spreading of this potassium thiocyanate. And then on the far right is the small amount of potassium nitrate added to the dish. In this video, the potassium nitrate is swirled to yield the same dark red transparent solution, and in the middle, a little bit of sodium phosphate is added, which then when mixed goes back to equilibrium in a clear solution. On the left, 1 drop of iron nitrate is added to the side of the dish, and a small amount of potassium thiocyanate is added onto the other side of the dish. On the video on the right shows the mixing of these 2 solutions, which then yields back to a clear solution. In the picture on the left, test tube B is the tube placed in cold water for 3 to 5 minutes, and compared to the control tube A, the result was foggy. On the right, test tube B is placed in hot water for 3 to 5 minutes, and the result is clear. This data table concludes the color changes of clear to orange, transparent orange to dark red to dark red to light orange, clear to dark red, and red to foggy clear. Analysis questions. Iron 3 ions plus thiocyanate ions yield iron thiocyanate 2+, iron being yellow, thiocyanate being colorless, and the end result being dark red. When iron nitrate or potassium thiocyanate was added, the color of the solution changed to become clear, with an orange tint for the former and red for the later. When the concentration of the reactants are increased, the forward reaction is favored, resulting in the red color change. The reverse rate decreases as the concentration of the reactants increases. When potassium nitrate was added to the solution in step 6, the solution turned dark red. The forward reaction became favored because the concentrations of the reactants increased from the potassium nitrate. When phosphate ions were combined with iron ions, the solution became a lighter orange. The reaction became favored towards the reverse reaction because of the iron ions being taken out of the system. When iron ions were introduced to the system, the solution changed to a red color. When the thiocyanate ions were added, the solution became clear. This proves both ions are present because the change in concentration made the color change in favor of the reactant added. When the solution was cooled, it became darker. When the solution was heated, it became clear. These results demonstrate the reaction occurs in both forward and reverse reactions because when heat is absorbed and released, the reaction goes in both forward and reverse directions. The forward reaction is exothermic, as followed by this equation. Effect of introductory activity on assigned activity. By conducting the introductory activity first, it helped to set a guideline for determining the procedure necessary for the assigned activity. We were able to effectively determine a method for testing Le Chatelier's principle of temperature, and this enabled us to recognize how a color change could indicate equilibrium. Materials for activity A: bromothymol blue, hydrochloric acid, sodium hydroxide, distilled water, graduated cylinder, stirring rod, test tubes, test tube rack, and wash bottle. Here is the procedure for activity A. Lab for activity A. In this video, 2 milliliters of distilled water is placed into a test tube and 5 drops of bromothymol blue is added. For this video on the left, HCl is added, and for the video on the right, NaOH is added. To test the effect of temperature, in these videos we add HCl to the bromothymol blue solution in a hot beaker of water and a cold beaker of water and test the differences. The same test is made for temperature when we add NaOH to the bromothymol blue in hot and the bromothymol blue in cold. In both of these videos, the solutions are cold, and either NaOH or HCl are added to make the system go back to equilibrium, in which they do in these two videos. In these two videos, the systems were heated, and when HCl or NaOH were added, the system either didn't reverse or there was no change. Evidence of changing colors. Water and bromothymol blue created green. HCl with water and dye created yellow, and NaOH with water and dye created blue. How temperature changes solution. In an ice bath at 279 Kelvin, HCl and NaOH were both able to go back to equilibrium. But with hot water at 333 Kelvin, HCl nor NaOH did not reverse back to equilibrium. Conclusion. In our introductory activity, we studied the reversible reaction of iron 3 nitrate and potassium thiocyanate. In the assigned activity, we observed the effect of how the reaction was influenced by an acid and a base indicator. The color changes happen in each reaction due to the addition of either crystals or another solution that caused the reaction to shift in a particular direction. When it was seen that the reaction could change color back to the original color of the system, demonstrated equilibrium had been reached prior. Our original hypothesis was incorrect because we had initially assumed both reactions would return to equilibrium and would react at different speeds. We thought the cold reaction would be slower than the fast, but by experiment we determined that both reactions happened at approximately the same rate. In reality, only the cold beakers returned to equilibrium while the hot ones did not. Error analysis. Possible errors in the activity portion include: before adding HCl or NaOH into the test tube, we didn't leave the test tube in the hot water or ice bath prior. The temperature of the two baths could have changed between each test. In intro activity, the temperature of the beakers was not measured with thermometers when the water was added for the hot or cold baths. Thank you, and I hope you enjoyed.